Welcome to breadboarding. In the previous videos we've been looking at building a 386 breadboard based PC based on the Compaq DeskPro 386 16MHz version, and this was one of the first 386 based PCs which was released in around 1986, so it's just coming up to 40 years later on this year. Now this is the PDF output of the schematic diagram that I put together for the DeskPro 386. And what I'm going to be doing in this video is showing you how to download KiCad 10, which is the PCB and schematic diagramming tool that I've been using for all my projects. And I'll show you also then how to download the schematics from GitHub and actually have a look yourselves. This is video number 8 in the 386 breadboard PC series, and we're looking at KiCad 10 and the DeskPro 386 schematic. So I'm going to have a look at a version of Windows 11 running in a VM. This should be full screen mode, and this is just a Windows 11 VM running inside VMware, which you can now download for personal use for free. So this is the KiCad homepage, www.kicad.org. The URLs will be in the description below. Just hit download, Windows, and we'll choose CERN, and it will start to download in the background. You can see it's downloading there. I'll speed this bit up. Then we'll just click on the file. It did take a while to uncompress that. So just going to do it for all users. I'll just do everything for now. Okay, so that's probably taken just over 5 minutes or so. So we'll now launch KiCad. So just go through the basic settings. We'll start the default settings, take the defaults. There we are. So all we need now is the project file for this. So there are some demos with it, but I'm going to download the DeskPro 386 schematics from GitHub. So if you go on to GitHub, Breadboarding Labs, the URL will be in the description below the video, or just Google for Breadboarding Labs GitHub. And the DeskPro 386 project is now up on here. It should be public, so you should be able to see it. So there's a bit of background in the README here, in particular about the KiCad schematics, which we'll go through in a minute, because there's a few things we have to do with the project library to set this up. You can also see that there's some of the PAL ASM files that have been converted from the PDF. I'm still in the process of migrating those into CUPL and testing those, but I will do an update video in about a week or so's time to go through all of those. In KiCad, we've actually got the project for the DeskPro 386, and there's also the schematic symbol file, which has got all of the project-specific chip layouts and things. And those are all of the project files for KiCad. Now, probably the easiest way to download this, you can use GitHub or Git, but probably the easiest way is just to download a zip file. And then we'll just move this to Documents. I'll put it outside KiCad for the moment. Extract all. So we may end up with an extra folder in here, but that's okay. Yeah, so we do have 2 folders here, but that should be okay for now. And then we've got KiCad. So we've got the symbol library, and then we've actually got the project in here. So what we can do now is to go into KiCad and open this project file. There'll be a delay whilst it loads some of the libraries for the first time. It took a while to actually load those libraries, but now we can see that we've got the schematic file here. Now, before we open the schematic, we do need to change the preferences to add the symbol library. So if we look back at the instructions here, so the internal design document schematics have been reproduced in KiCad 10, so you can't use earlier versions of KiCad. I've laid them out in one big diagram so that related pages are closer together to make tracing labels easier. So one of the things I find is when you have the multiple page diagrams which are nested in a hierarchy, it's quite difficult to try and actually work out how things are working. Whereas when things are on one big diagram, when you highlight something in the highlighter, you can see everywhere where that would actually be used. So if you want to change these diagrams, feel free to download them and hack around with them how you wish. Now, many of the chip symbols have been made to look like the DeskPro schematic. So the DeskPro schematics generally don't include the +5 and ground pins in them, and they're actually arranged in a certain way to suit really the layout of the schematic. So what I've done is I've made a number of these to suit the DeskPro, so they will have a DP in the name. All we have to do is use the Preferences, Manage Symbol Libraries, then select the Project Specific Libraries tab and select the path to our breadboard in KiCad symbol library. So go into Preferences, Manage Symbol Libraries, Project Specific Libraries, and we'll just need to make sure that the folder structure in here is actually correct, because this will be for my main PC rather than the VM here. You can see that the symbol library is actually one folder above the DeskPro. This symbol library can be used across multiple projects that I use. Okay, so that should now have set it up so that now when we go into it, we shouldn't have lots of symbols which it can't find. Now open the schematic. The first time I went in here, it didn't actually show all of the schematic here. What it did do is just do Control A to select everything, and that seems to have brought it all back. So I've got the schematic here coming out. What I'm going to do is to switch to my main PC now. We've got this installed and configured and open properly. There are just a few problems with the VM and the OBS software capturing the VM output. That means that it doesn't quite show all the lines and things. So that's how to go about downloading KiCad and actually loading the DeskPro 386 schematics that I've uploaded onto GitHub there. So in fact, this is now the KiCad running on my main PC rather than the VM. I just wanted to show how to install it on a clean environment. So you can see here that hopefully when we zoom in here, it'll look a bit better. The top here, we've got the 32-bit memory card. So we've got the memory card diagram number 2. So invariably the first diagram in the DeskPro manuals just had the sort of introduction stuff, didn't really have anything of interest. We've got the memory decode and multiplexers, some of the ROM mapping and the dynamic RAM RAS-CAS strobes. And then there were quite a few sheets, and what I've just done here is just show there's a buffer here, some resistors, and then each of the dynamic RAM chips. So each block of dynamic RAM chips has 9 chips in total, so 8 for the data plus 1 for parity. And the way how these are organized is that you tend to have the D0, then you'd have D1, D2, D3, and then the final one would be D7, and then P0 would be parity. And similarly for sheet 6, 7 and 8, then you again have the D7 to D15, D16 to D23, and the D24 up to D31, and then the different parity settings there. So getting 32-bit memory boards was quite cumbersome, and until SIMS and DIMS, the memory modules, came in a few years later, then this was the only way to do it. So we've got the 386 processor here. I have got a pin out for the top down from the datasheet there, just to help in mapping the various ABC and numeric references on here. So you can see here we've got A to P, 1 to 14. This is a top-down pin layout looking from the top of the chip. And the corner piece here and the dot refers to where pin A1 is. This 32-bit memory connector connects the CPU to the memory board over here. So this was basically direct connection straight into the data bus and the address bus of the CPU to minimize latency. We've got all of our address latches, data buffers, and what you can see if we drill in here, these are some of the programmable logic devices, and you'll see here this is a D4 SMS CD. If we look up into the design document, you'll see the details of this, and you can see that what I've done here is I've actually made the pin layouts generally specific to each of these PLDs. These pin labels should generally match the PAL-ASM and the CUPL PLD definitions. One of the nice things about KiCad 10 is that now where we have wires that overlap, then you can now include this sort of hop over. So if you've got existing diagrams, you can enable that. In the formatting, we can see hop over size. That's none, then you won't see it. Smallest is a bit too small, the other's a bit too large. So I think small is about the sweet spot for that. And that makes the layout a bit easier to see, certainly when things are meant to be joined versus accidentally being joined. And the reason for doing it this way is if we wanted to trace a particular pin, for example, if we use the highlight nets. So for example, if we're looking at the memory read control signal, for example, which comes out of this command decoder. So these are some of the signals coming from the CPU, which then decoded into the IO read, IO write, and the memory read, memory write signals. And we can then see that that is then going off to various other places. And there is also these global labels then will allow connections between the different diagrams. In some cases, I may join up those, but it just means that we can actually see where that is actually in use. You can see also there are some connections here, for example, here as well. So in trying to work out what these PLDs are doing and converting them into the modern WinCUPL syntax, it's still going to probably take me another week or so to get that done. What this should allow you to do is if you want to, you can go in and actually have a bit more of a detailed look at what's going on. Obviously, if you see problems and things, then by all means let me know. Most of these chip layouts are custom. So for example, if we have a look at the details in the schematic editor for this, see that, for example, this one will in fact be an Intel 8237, but it's got the DP for the DeskPro. And that means that these pin layouts here have actually been changed to actually match the diagrams. We have a look at one of the other ones here, the breadboarding one. You'll see the breadboarding one has the pin layout, so 1 to 20, 21 to 40. So I tend to do my symbols within the KiCad diagrams actually matching the physical layouts. That means that when we're actually laying out the chips in the schematic, then it pretty much matches what the breadboard layout will be. So if we have a lot of wires going around corners and things, then that indicates it's going to be messy to wire up. So I find that using the physical chip layout like this makes it a bit easier to use the schematic actually as a breadboard layout. And we also see up here that a number of the PLDs, you can see there's the ATF 16V8B, which is one of the smaller PLDs that are used here. And you can see there's a number of the DeskPro PLDs here. And you can see here we've actually got the label that is used on the schematic for each of those. And there's a couple also then for the ATF22V10 as well. Now the size of this is really quite large. You see here the height and width. So the height is 40,000 mils, so thousandths of an inch. So that's 40 inches high by 73 inches is the scale of this. And I think I worked that out that compared to the European A0 size, that's about 1.5 times wider than the A0 size. So I needed that really to get enough of the diagram in here, but certainly makes it a lot easier to skip around and see how things are connected up. And certainly being able to see everything in one page makes life a lot easier. And where we actually got the PDF from, if you go into plot, you can then actually plot a PDF. Plot the current page will create PDF. Just a word of warning, I did have some problems with Acrobat, was struggling to read the file sometimes. And you'll see that when we drill down into it, sometimes it takes a little while to catch up. And that, yeah, some of the lines take a little bit of time to for Acrobat to actually change from the low resolution to the high resolution. So I'm going to leave the video there. So in the next video, I'm going to be carrying on looking at the laying out of the buffers, latches and the control logic, getting the PLDs for the control logic, which is very much these ones here, 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 and all these chips, getting all these worked out so we can actually lay them out around the processor is taking quite a while to get sorted, but hopefully within the next week or so I'll have the PLD rules for these old PAL ASM format files converted into more recent WinCUPL2 syntax. So if you don't want to miss out on future videos, please hit subscribe, and if you found the content interesting, please hit like, just helps to make the videos available to a few more people. If you'd like to leave comments below, I do try and get back to comments within about 24 hours where I'm able to. Thanks for watching.